Hi everybody, this is David Peacock here, and today we are going to be learning about something you've already learned. So it's going to be easy, no surprises. That's right, we're talking about the Pythagorean Theorem. A squared plus b squared equals c squared. So let's get ready. This is geometry. It's going to be so easy. All right, so let's do what will be our easiest lesson, the Pythagorean Theorem. Seriously, you learned all this in like middle school. So here's the Pythagorean Theorem. In a right triangle, the sum of the squares of the legs is equal to the square of the length of the hypotenuse. So a squared plus b squared equals c squared. Like I said, you've already seen this before. Just to make sure though, here are some nice little animations that I found from the internet just to kind of show you how a squared plus b squared is equal to c squared. The two smaller squares end up adding up to be the big square. That's it. So now that we've done that, let's try it out ourselves. So here's our first question. It says find C. And of course, I'm going to say, here it is. And now that I've made that hilarious joke that none of my students have ever made, let's go on and actually do it the right way. So we have a 5 and a 12, and we're looking for C. So what we have to do is use the Pythagorean theorem. 5 squared plus 12 squared equals C squared. So let's see, 5 squared is 25. 12 squared is not 120 something, it's 144. And that's going to equal C squared. 5 squared, 25 plus 144 is 169, which is c squared. Then we square root 169, and the square root of 169 is 13, meaning c is 13. There we go. All right, let's try this one. Ooh, in this case, we know the hypotenuse, and we know one of the legs. So let's plug this into our formula. So we have 4 squared plus b squared is equal to 5 squared. So that's 16 plus b squared equals 25. We subtract 16, meaning that b squared is 9. We square root, and b is 3. Now, both of these have something in common. We had a 5, 12, 13, and now we have what's called a 3, 4, 5. And both of these are Pythagorean triples. Ooh, this might be close to new. I hope it's not. Okay, so a Pythagorean triple consists of 3 positive integers, a, b, and c, such that a squared plus b squared equals c squared. Quick reminder, integers cannot have decimals. So a squared plus b squared equals c squared. Now, some common Pythagorean triples are 3, 4, 5, which we just saw, 5, 12, 13, which we also just saw, but also 8, 15, 17, and 7, 24, 25. There are so many other Pythagorean triples out there, but I just didn't want to list them all because literally I could list them for hours. This could be the world's longest video, one of those 10-hour YouTube long plays, and I would still not be done. Although my voice would be at that point. Probably forever. But one thing I will point out is that any Pythagorean triple can also be multiplied. So a 3, 4, 5 can also be a 6, 8, 10, or a 9, 12, 15. A 5, 12, 13 could end up being a 25, 60, 65, any of those type of things. So that's important for us to remember. Now, let's go back to actually trying out another one. This one is, well, we're just out to find C. This is like that first question. This will be easy. I bet this is a Pythagorean triple as well. It's 4, 6, so 4 squared plus 6 squared equals C squared. So 4 squared is 16. 6 squared is 36, and that's going to equal C squared. 16 plus 36, 46. That is 52 is equal to C squared, so we square root and Did I write this wrong? 52. I think it must be 25. No, it's not. Okay, but 52 doesn't work. Well, I mean, I guess I can square root it and get a decimal. I legitimately hate decimals. So I guess we're going to have to do something about that. All right. We're going to talk about simplifying radicals real quick, but that's the only new thing. Swear. Let's go. All right, so if we want to find the square root of 52 while simplifying radicals, we are wanting to break down the radical of 52. So I like to do what's called prime factorization. What is a number that I know goes into 52? In this case, it's even, so I know 2 goes into 52. So I do 2 times 26. All right, so the square root of 2 times the square root of 26 is the same as the square root of 52. Now, 2 I can't break down anymore. It's prime. The only thing that I can do is say like 2 times 1, and the 1 is worthless because the square root of 1 is just 1. But 26 I actually know is 2 times 13. And notice right here we now have a square root of 2 and a square root of 2. Now I bring that up because the square root of 2 times the square root of 2 is the same as saying the square root of 2 squared. And whenever I square root something and then square it, I cancel those out, meaning the square root of 2 times the square root of 2 just becomes 2, leaving us with 2 square roots of 13. All right, so now we're going to try this with a number that's just a little bigger. And that number is 35,280. Now, I'm actually going to go with a much larger prime number to start with because I don't want to go with 2 because 2 is going to be too small. But I want to go instead with 5. See, it ended in a 0, which means I knew it was a multiple of both 2 and 5. So 5 times, well, let's see. 35 gets us 7,000. Let's see, 7,002, so that's 0. 28 gets us 5. That leaves us 30, so 7,056. Okay, 7,056. All right, so now we're going to go with 2, I guess. 2, so let's see, that's 3. And then we have 3, 5, 2, 8. That means we can do 2 again. So 2 times, so that's 1, 7, 6, 4. So now we can go 2 again. That's 882. So 2. And that's 441. Okay, 441. Ooh. Okay, so let's see. What numbers do I know go into 441? Well, actually, I know 3 goes into 441. So this becomes 3 because 4 plus 4 is 8 plus 1 is 9, which is a multiple of 3. So that's 3 and then 14. So 1 and then 14 would be 2. And then 21 is 7. 127 is also a multiple of 3. That is 3 times 49. And 49 is 7 times 7. So let's see. We have a pair of 7s, a pair of 3s, a pair of 2s, another pair of 2s, and a 5 all by itself. Any pair that we have, we get to pull out. So this becomes 2 times 2 times 3 times 7. And inside the square root, we have whatever is left over. All of these were canceled out by getting closer, but we still have a 5. So 2 times 2 is 4. And then let's see, 4 times 3 is 12. And 12 times 7 gets us 84 square roots of 5. And that is how we simplify radicals. Back to the Pythagorean Theorem. All right, so this says find C, 8 for C, so I'm just going to do 8 squared plus 4 squared equals c squared. So let's see, 8 squared is 64 plus 16 equals c squared. 64 plus 16 gets us a beloved number of 80 equals c squared. So we're square rooting that, square rooting 80. That's 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. We have 2 pairs of 2's, so that's 2 times 2, square roots of 5, or 4 square roots of 5. Ooh, I had another square root of 5 there. Interesting. All right, and that's it. That's everything we need. We talked about how to find a missing side with the Pythagorean theorem, how to simplify radicals. What else would you... Right. So did you know that the Pythagorean theorem could also prove if a triangle is right? That's correct. You can actually prove if a triangle is right, acute, or obtuse using the Pythagorean theorem. And I guess we're going to talk about that too. All right, well, I guess we're going to talk about the converse of the Pythagorean theorem. So remember, the converse is where we just switch the order. So in the original order it was, if a triangle is right, then a squared plus b squared equals c squared. Well, the converse of the Pythagorean theorem is, if the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse, then the triangle is a right triangle. So if a squared plus b squared equals c squared, then a triangle is right. So that's our first thing that we're going to know. So if a squared plus b squared equals c squared, then we know it's right whether or not we see the little box. But what if a squared plus b squared doesn't equal c squared? What if a squared plus b squared was greater than c squared? Well, that would mean that c was getting smaller, so it would look something like this. So when c gets smaller, what this ends up doing is it actually stops the triangle from being right. It's not a right triangle anymore. It's actually acute. So if the squares of the legs is greater than the square of the, longest side, then it's acute. And what if a squared plus b squared is smaller than c squared? Well, that means c is getting bigger. And if c gets bigger, well, it starts to look like this. So if the sum of the squares of the two smaller sides is less than the square of what amounts to the longest side, then it's obtuse. There we go. Let's try that out a little bit. So, acute, right, or obtuse. This is our fun little game that we have here. Dun, 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 dun. So, what we have here is 3, 4, and 7. So, wait a second. I have to check something out. First, before we can actually play the game of is it acute, right, or obtuse, we have to play the game of is this a triangle? So, here's our simple rule. For it to be a triangle, no two sides can be equal or less than the third side. And wait a second, 3 plus 4 is equal to 7. So the answer is not a triangle. All right, so let's try this again. Here we have 15, 36, 39. Okay, so we're going to try this one. 15, 36, 39. So I'm going to do 15 squared plus 36 squared, and then we're going to do 39 squared and compare them. So I'm going to be honest here. I could do this, using like actual working it out, but I'm just going to get a calculator real quick. And I'm going to do 15 times 15. So that's 225 plus 36 times 36. And that gets us, so that gets us 1,521. And over here, 39 times 39, 39 times 39, that gets us 1,521, which means they're equal. So this one is right. Oh, by the way, this was one of those Pythagorean triples. It's actually one that we did earlier today, because 15 divided by 3 is 5. 36 divided by 3 is 12. And 39 divided by 3 is 13. Whoa, what a shock. All right, now we have one that says 15, 21, 25. Okay, so we're just going to do 15 squared plus 21 squared plus 25. Or not plus 25 squared. We're going to compare that to 25 squared. So 15 times 15 plus 21 times 21. That gets us, that gets us an interesting number right here. I'm just going to write it down and we're going to move on. And then let's do 25 times 25. And that gets us 625. Well, 625 is smaller than 15 squared plus 21 squared. So that means it is acute. Now we're going to move on. So here's another question. We have 12, 6, and 16. So in this case, we are going to do 6 squared plus 12 squared. And that is going to equal 16 squared. So 36 plus 144, that's 180. And then 16 squared, 16 times 16, and that is 256. Well, 256. First off, this was a triangle. Wait a second, this side's bigger, which means it is obtuse. And that's it. We're really to the end of the day. And that's it. We're really to the end of the video. Thank you all for watching. Please remember to like, review, subscribe, all that stuff. Goodbye. That's it. We're to the end of the video. Thank you all for watching. And that's it. We're to the end of the video. Thank you all for watching. Please remember to like, review, comment, any of that stuff. Every little bit helps expand my base to literally still just all of you. But thank you all very much. All right, and that time it really is it. We've talked about everything that we need to do. The only thing left is for you to like, comment, subscribe, all that jazz. Please tell your friends to do it. Tell celebrities. Tell everyone to follow me, because who doesn't want more geometry videos? Who? Bye.